Hello and welcome. Today we are carrying out a comparison test between Kimi k2.6 and OpenAI's Codex 5.5. Now k2.6 was launched about 3 days ago, about 72 hours now. This is the 24th, so well into 3 days ago. And Codex 5.5 was launched about 24 hours ago. Really impressive models, really impressive benchmarks, really impressive statistics and all of that cool stuff. However, benchmarks are just half of the story, and I like to put these models head to head to see how well they perform. Now, Kimi k2.6 is an open source model. However, it is a really impressive model and the benchmarks is wild, right? And then we have Codex 5.5, a state-of-the-art model that honestly is just really, really impressive. It is closed source. They have a ton of money to develop this model. And, it's just a really fun test to put it up against an open source model. Without wasting much of your time, let's get right into it. So I like to run these tests with what you could consider a rather practical set of prompts, right? I had used these prompts in my previous test of Kimi k2.6 versus Opus 4.7 and Kimi k2.6 versus GLM 5.1 as well. And just using the same set of prompts with Kimi against Codex 5.5, right? It's fairly practical, honestly. It tests a bunch of things, a lot of it being how well the model was able to take one single prompt and produce an output with zero modification. It tests the model's performance in front-end development, technical development, and how well the model is able to give us really dynamic functional results. So we do have 5 tests in total with a bunch of evaluation criteria. So we're going to start with the first one and go side by side between Kimi k2.6, which is right to my left, and Codex 5.5 to the right. So the first one is a particle fluid simulation, and this is sort of what that does. As you can see, it's just working with particles on the front end, and we can modify gravity. We can increase the viscosity or reduce that, and reduce gravity as well. And so once we do this, we're just able to play with the front end. One of the evaluation criteria here is to ensure that we consistently stay at 60 FPS, which is what is happening here, which is great. And it is interactive. Nothing breaks, everything works really well. This is Kimi's version. Kimi does pretty well here. I'm going to go ahead and see how well Codex recreated this exact same prompt. Now, one thing I'm noticing right off the bat is the fact that Codex's version is buggy. It's losing a bunch of frames. We're barely at 60 FPS. And as you can see, it is progressively moving. The particles aren't fluid. And we can barely interact with the front end, which is a little bit disappointing because this is supposed to be a really impressive model, but it doesn't, this doesn't work. I think it's probably eating up at my RAM at the moment. Okay, it's not, so that's good. But we can barely use this. So right off the bat, Kimi wins this version. There's nothing to say here. Codex. So the particle fluid simulation test, Kimi wins it 1-0. I'm just going to have to close this page so we can move on to the next prompt. Now you probably already do have a sneak peek into this, but we will come back to that. Okay, so the second prompt is a technical algorithmic visualization. Create a single file interactive artifacts that visualizes 8 Pathfinder algorithms running simultaneously on the same grid in a 4x2 layout. So these are the results. Again, there are a few evaluation criteria here, and we can see how different they both sort of implement the exact same prompt. So the evaluation criteria are pretty simple. Are all 8 algorithms implemented correctly? Do they actually produce different exploration patterns? Is the 4x2 layout readable? Does it look like a real tool or a weekend hack? I like the barcode design that Kimi went for, I have to say. And if we try to see, so we're going to run a test to see if they work. It says no path because it cannot find its way from point A to point B. And if we randomize, clear the walls, that works. And that works well. If we try the same thing with Codex, it works fine, but it's really slow. I mean, it says it takes 2 milliseconds, but the actual progression time is much slower. So something isn't right here. Honestly, this is a very interesting test because, it's the results here are rather interesting. I'm going to reset this and run the race again. It's taking the time it is taking Kimi to finish these different algorithms varies, and we can see them. But when we work with Codex, it says 0 right here. It says it took it 0 milliseconds to get it done. 2 milliseconds to get this done. The Codex's version is really, really buggy. It's pretty bad. And if we add some obstacles and try to generate the race, it's much slower. It's so slow. Codex's version is really slow. It's just really slow. Honestly, it feels like I want to spend a lot of time on this to figure out what is happening, but we don't have all day. So in my opinion, Kimi wins this version. If you do have a different POV, let me know. I'll happily consider that, but it's just pretty obvious. The UI is better, it looks better, and it just functions better. So 2-0 right now. That is something. That is crazy. Kimi k2.6 is leading 2-0 against codex 5.5. And now the third test, I think this one's actually a really fun test, is a technical 3D and state management. The goal is to build a simple HTML file that sort of gives us a view of the solar system and interact with them and be sure that things are actually functional. So this is Kimi's version to the left, and this is Codex's version to the right. And it's pretty seamless. It's a lot more fluid, ever so slightly more fluid than Kimi's version. However, it's not bright. It feels dark, and there are a lot of bugs here. So, okay, when I zoom in, we can see the sun, but the planets here are a lot more defined. Like, look at Earth on Kimi's version, and look at Earth on Codex's version. Dude, what the hell is this? Like, this is Codex 5.5, and these are the results we're getting with the exact same prompts. It makes zero sense to me. Again, this is what Earth looks like. And oh my, so cooked. Codex is so fucking cooked, because there is no way this is what we're getting from a model that is worth, because there is no way this is what we're getting from a model that has billions and billions of dollars poured into it. And this is what we get from an actual open source model. Look, Earth is really defined. We can look at Earth. It is defined here in Kimi's version. This is Kimi k2.6 version. And this is what we have from Codex 5.5. It's a circle with blue. It's a circle in blue. That's all we have. And look at Venus. Look at Mercury. Look at Mars. Look at Earth on Kimi's version. Look at Venus here. Just take a look at that. It's insane. This makes zero sense to me. It makes zero sense to me. All right. And these are the exact same prompts, two different models, and Kimi k2.6 is outperforming Codex 5.5 by a mile. My mind is absolutely blown. And this is just, what a time to be alive, honestly. Yeah, nah. This is insane. All right, it is pretty obvious. Kimi k2.6 wins this round. It's not even a competition, honestly. We're going to move on to the next test. So our fourth test is a remotion test. Remotion is this really cool tool that allows you to create motion graphic with code, and a lot of the AI tools do really well. Opus, so far, in my experience, has been the champ. It's been outperforming all of these other models by far, but I still had to run the test, putting Kimi against Codex, and these are the results. So this is Codex's version, and I'll show you Kimi's version right after this. So it is a simple explainer video prompt where we're supposed to talk about closed source models and then talk about open source models and how far they've come in the past 2 years. And that's just like, you know, what's supposed to happen here. Now we can see it's not great. There's so many things that are sort of like, you know, all over the place. But for a bit of context, I'll show you what Opus gave us with the exact same prompt. This is Opus's version. You can see a bunch of things are ever so slightly different. Again, I wouldn't say this is the best version or this is as good as it gets when working with Remotion, but you can tell the difference between these models, and that's the point I'm trying to get across. All right, so that is Codex and Opus's version, and I'm going to show you what Kimi k2.6 did. So this is Kimi k2.6's version. Again, same exact prompt, you know, explainer thing, closed source, open source models, and yeah, nah, not great. It's not great in my opinion. It's pretty mid. But Kimi's strength has never really been with like Remotion and stuff, so I didn't expect it to do anything more than it's done. So this is pretty much it. So that is it. That is what we get from Kimi, and that is what we get from Codex. I do think that I think Codex wins this round. So, you know, we give something to Codex for this competition. So our last and final test, it's a UI design task that I gave both of these models. So I got this design from Dribble. Shout out to the creator of this. I do not own this. I got this design and I just gave it to the agents to reproduce this, and these were the results. So if you can't tell already, the one to the left is Kimi's version and the one to the right is Codex's version. And again, not too far off, but we can see a bunch of things that makes Kimi's version stand out, you know. For one, we have this really fun animation, even though it's not really great when we reload the page. We don't have that in Codex's version. They never really get the dashboard design right. Like this overview, this sales overview, they never really get it right. This is what it looks like, and this is what they do. And I've run this test with Opus, Codex, GLM, and Kimi, and they all sort of just do the same thing, and they never really do get it right. Anyway, everything else seems fine and functional. They both sort of fall short here in the sales distribution chart. They both fall short here, but everything else is good to go. We didn't really optimize for responsiveness, so neither one of them is responsive, so that's fine. We're not really specific about that, but I think Kimi is sort of web responsive, not mobile responsive. I guess it's about the same thing. So yeah, performance here isn't too crazy. I think they did pretty well. It's a tie for me here, just because Codex never really got this right. If it did, I probably would have given this to Codex, just because at this point we sort of might need to give Codex something. So yes, and yeah, this is the final test. Let's go to the verdict. Okay, so we just ran a rather extensive test, a non-scientific one, but extensive nonetheless, an insightful test, and the results were shocking to me, I would say. I did not expect a model that was just released to be outperformed by an open weight model, but what a time to be alive. It pretty much means to an extent, if you're working with Kimi k2.6, I guess especially if you're building front-end heavy user interfaces or front-end heavy product, you can rely on Kimi to produce really good code. Codex's version for front-end did not do a really good job, especially when we're working with a bunch of elements, right? Like 3D.js, gravity simulation, fluid simulation. It just fell apart. It was just bad. So pretty obvious from what we just saw that Kimi k2.6 is the obvious winner here. It's been about 3 tests I've run, and Kimi is on a streak. It's been, going back to back and just taking the crown, which is really impressive in my opinion. Kimi is the model of the week, I guess, but again, it's an open weight model, so it's hard to not be impressed by its performance. But if you just saw what I saw as well, Codex never stood a chance. It just never stood a chance. So that's pretty much it. If you liked this video, please give it a like. I'll be making more videos like this one. I've made several videos like this where we're actually taking open source models and closed source models, or just AI models in general, and putting them through actual practical tests. The benchmarks are great, but tests like this sort of tell us what to expect when working with these models, and we sort of know what tool is right for the job. So if you like this, subscribe. I make way more videos like this and way more tech, AI, programming, software engineering videos. Looking forward to seeing you around. Thank you for watching, and I'll catch you in the next one. Peace.